access. I don't have
You
access to
don't
the resource center.
you don't have access to recordings?
No.
Have you asked for it?
Yeah, a couple months ago, just no one got back to me on it.
Okay, I'll talk to the admin and I'll get back to you, okay?
Okay, thank you.
Okay, no problem. Okay, so this is the population. So for
Yeah.
example, if I select 5 students from this,
Okay.
I select students with the marks 3, 7, 8, 9, and 11. So
Okay.
these 5 students are my sample.
Okay.
Okay. The population is, for example, I take whole of Dubai, and then I say I'm taking uh only the region of for example Dera. Okay.
Okay.
That would be my sample. My population would be the whole of UAE or Dubai.
Okay.
All right.
Okay. Okay.
You understand?
Yes, I
So
do.
this is my sample. So what happens now is when you calculate the mean of the population, which is mu, this is equal to the mean of estimated mean of the X bar.
Population.
X bar is
Okay.
basically the
Okay.
mean of the sample. Do you
Okay.
understand? This is
Yeah.
equal to this. Okay. This is the same. But when
So
we talk,
mu and
so
x bar is the same.
X bar and mu is no, the estimated X bar and mu is the same. This is
Okay.
called estimated. Okay.
Okay.
Like this means if mu is 9, so X bar may be 8.7 or 8.8. So we
Okay.
just say it's the same, okay? Because there's like point 1, point 2 level of error.
So we can
So we
consider
call it
it the same.
estimated S bar, X bar,
Okay.
okay? We don't say X bar, we say estimation of X bar, okay?
Okay. Yep.
So next is what we have to find out, the variance, okay?
Okay.
I told you the formula for variance in the last class. You remember?
Wasn't it just estimated value of x minus x bar over n
Yes.
squared, sorry, squared over n.
So it was what was it? Okay, yeah. It was basically estimation of summation of x minus x bar
Squared over n.
square upon n,
Yeah.
right?
Yeah.
Yeah. So you understood what how we find out x minus x bar summation of this? So I'm just
And
gonna give you a overview of how we solve this. Okay. For example,
okay.
if they've given you summation of x square,
Okay.
this and summation of x whole square, these both
Okay.
are very different things. How do
Okay.
you read this? You read this by you sum of x values squared. This means every x value you have to square and then get the sum out of it. For example, I
Okay.
have to find out the summation of x square and these are my values, okay? So I have to
Okay.
do 3 square plus 7 squared plus 8 squared plus 9 squared plus 11 squared.
Okay.
However, over here, how do I read this? Summation of
X squared.
x then squared.
Okay.
First, you take out the sum of x, which is 3 squared, 7 squared, 8 squared, 9 squared. No, you take out the sum of x. So 3 plus 7 plus 8 plus 9 plus
All
11,
squared.
and then you square it. So these
Okay.
values will be very different, right?
Okay. Yes.
Yeah. So when it comes to this means summation of x minus x bar then squared. This
Yeah.
means you have to do, for example, my x bar is 6. So I
Mm.
have to calculate x minus x bar. So this is a column for x minus x bar, and then you can make a column for x minus x bar whole square. So for example, over here I have to do 3 minus 6, x is 3, mu is 6, 7 minus 6, 8 minus 6, 9 minus 6, 11 minus 6. Then whatever you get over here, you get minus 3, you get 1, you
One,
get 2,
three,
3,
okay.
and
Five.
5. So you square this. So it becomes 9, 1, 4, 9, 25. Do you understand? Then when you add all of this, so you get summation of this.
Wait,
You
wait, wait.
understand?
So to find the yeah, so what you did was 3 squared plus 7 squared plus 8 squared, whatever, minus plus
Yeah,
the other side, and then you got x bar, which was 6, and then you just did x minus x bar, and then you squared that, those values.
yeah,
Okay,
exactly.
great.
You understand? Now
Yeah.
when I add all of this, I will get summation of x minus x bar whole squared. Do you understand?
Okay. And then you just divide it by how many? Okay,
Yes,
now
then you
you
just
divide
divide
it,
it by n.
do you divide it by the sample or the population? Sample, right?
This is the population. Right now I'm talking about this is the r square is the variance of the population.
Okay.
When we talk about sample, we write s squared, not
Okay.
r squared.
Okay, got
Okay,
it. Okay.
got it?
Yeah.
Okay, can I erase it?
Yeah, yeah.
Okay, all right. Now I'm going to talk about, so we talked about the formula of the variance of population. So now for the sample, the sample variance is called s squared, and s squared is equal to summation of x minus x bar, summation x minus x bar whole square upon n minus 1.
Hmm.
Okay, the only difference is this minus 1, but there is a difference in the formula, so you will have to calculate it again. You understand?
Yes, I do.
Are you clear on the formulas? Can I
Yeah,
move
it's just the
forward?
same thing, and then for the
Yes.
sample is just n minus 1.
Yes. So when
Okay.
you're reading the question, you need to be very careful if they're giving you the variance of the population or the sample. The
Okay.
question will be very clear on that. Okay?
Okay. Yes.
Okay. Now I'm gonna start with estimation. This was basically S1 estimation, which you have
Okay.
done before. I think you don't
Last year.
remember. Yeah.
Yes.
You in last year, I think you did not do the difference between population and sample. This is a part of
Mm.
S2, but you have done the formulas.
Yeah, I
Okay,
have.
you have, right? Okay.
Yeah, and discrete
Now,
random numbers.
one thing I want to tell you, I think I forgot when you were doing in normal distribution. When we approximate binomial to normal,
Yeah.
yeah, the two conditions were NP should be greater than 5 and NQ should be greater than 5.
Yeah.
Yeah. So when this is true, then we say CLT applies. What is CLT? CLT is central limit theorem. So when
Okay.
CLT applies, this basically means that now for any sample size, binomial will can turn into normal, right? So
Yeah.
now the distribution will follow normal for distribution, right? So we have mu and r squared. Okay.
Okay. Wait, I don't understand CLT.
The only thing is this: when you're converting binomial into normal, and this is true, you have done everything. You don't know the word only. So basically the term for this is CLT. So
Okay.
sometimes they will ask you how did you convert binomial to normal? You will say this is true, so CLT applies. That means for all values of for all values of n, whatever the sample size is, how big or how small the sample size is, binomial will be can be approximated to normal. Okay,
Okay.
understood?
So it's just about making a statement and that's it.
Yeah, it's just about making the statement. Sometimes they will ask you the reasoning. So you need to
Okay.
know the word. That's it.
Okay.
Okay. Okay. So now we're going to start with the three cases. So basically, you know, um, let me take out the question so I can explain you better. Um, Okay, so in estimation, we will be doing 3 cases in total, okay? So right now we
Mhm.
are doing case 1. So if you're making notes, just write the heading case 1,
Mhm.
okay? So this case is basically, 1 minute. So this case is abundant population. Okay, no, wait. We're going to do the cases later. Just understand this. You understand that the sample is an estimate of the population, right?
Yeah.
Yeah. Okay.
Yeah.
So the sampling distribution I'm going to write over here. The sampling distribution
Yeah.
for normal, and I'm going to write the population distribution over here. Okay.
Okay.
The sampling distribution we have for the population, let's first see. We have mu, we have r squared, okay, and over here we have, in sample we have x bar, which is the sample mean. We have we have ex is equal to mu, okay.
Mhm.
And so over here, do you remember our x would follow a normal distribution with mu and r squared, right?
Yeah.
Yeah, over here what the difference is, we will have x bar will follow the normal distribution mu and r square over n.
Okay.
Okay, this is the difference. Okay.
Okay. So let me just write it down. So the
Huh.
first case is that it's E
No,
and
this is
then
not
X
the
bar.
first case. This is not
Oh,
the first case. This is just an explanation. I'm just explaining you this, and then we will start with the first case.
okay. This is just like some information. I'll just write it down.
Yes, yes, yes.
So X bar is mu here, and in the previous one it was just, oh, it was the same thing, right?
Yeah, it's the same thing. Just guess. This is the difference.
Yeah, that's
Our variance was r square over here. Over here, it's r square upon n.
okay.
Hmm.
Okay, okay. You can.
Okay. Okay. Just give me a minute. When this is normal. Okay. Now I'll be starting with the um cases. Okay. So we're going to
Mhm.
case 1 first. Okay. So in this case, basically,
Yeah. Continue.
wait, let me first explain you the confidence interval. Wait. Okay, do you know what confidence interval is?
No,
No? Okay.
no.
So basically, what the confidence interval says, do you remember this? This is the normal distribution curve.
Yeah,
This is our mu,
yeah,
yeah, or this is 0. Okay. And basically, this is our mu, right? So what the
yeah.
confidence interval says that, for example, I say that there is a 95 confidence interval, 95% confidence interval, that probability that A and B, mu lies between A and B is 0.95
Okay.
or 95%, right? So how I
Yeah,
read this statement is basically, there is a 95% chance that mu lies between A and B. So A can be anywhere and B can be anywhere, right? So for example, A is here and B is here. So I'm
Okay.
saying this region is 0.95.
Okay.
Now you tell me, Naila, if this region is 0.95, what is the remaining region?
0.25, 0.25.
Yes, exactly. Well, how do you do this?
Because it's just 1 minus 0.95 divided by 2.
Yes, 1 minus 0.95
0.9
and then you
divided by 2.
divide by 2.
Yep.
So this is 0.25
25.
and this is 0.25.
Okay.
Okay? All right. So now what you can do is now they'll either ask you to find out the value of B or the value of A. Okay?
Okay.
So now you know how to find out the value of B or A, right? So you can either do how can you find out the value of B or A? You can either do X is less than B is equal to how much? What is the probability?
0.
0.95 plus 0.25, right?
Yeah.
Yes.
Yes.
So X is less than B is equal to 0.
95.
Plus 0.25.
I can't see the right side.
Okay.
Okay. You wrote less than for both of them.
Yes. I just wrote less than for B.
Oh, okay. Do you want me to add them for you?
Yeah. So 1
It's
minute.
1.2.
0.5 divided by 2. It's 1.2.
Yeah.
How can it be 1.2?
0.95 plus 0.25 is 1.2.
How much is the 1 minus 0.95, Naila?
1 minus 0.95.
Yeah.
0.05.
0.05. So then you divide that by 2, right? So it's going to be 0.025, not 0.25. Right?
Oh, okay. Yeah, my bad.
That is why we're getting more than 1. So when you do
Yeah.
0.95 plus 0.025, you get
You get 0.975.
0.975. So do you understand what this is? This is backward normal distribution. We have done this.
Yeah.
You look at the probability in the graph and then you
Yeah.
will be given mu and r squared. So you look at the probability and then you solve this, right?
Yes.
Yes?
Yes.
Okay. Okay. So now we're going to do the cases. So this was an explanation of confidence interval. One other thing you have to know is the width. Okay, they will ask you the width. Okay, wait. This is okay, and then they can also ask. This is one way. Another way is basically okay, to find out the confidence interval. You can also use the formula sample mean, which is x bar plus minus z r upon n. Okay. Now what you need to understand is, I will explain you this formula. What you need to understand in this case is, Naila, that right, this will give you the confidence interval.
Okay.
Why are we plusing and minusing? Because we will get both of the values, right? So
Yes.
you can either use that way, which we did right now, or you can use this way. This is all, but you need to know both ways, because some cases would be will not be able to use that way. Okay, because this is the case of a sample mean now. Okay, when we use sample mean, do you remember what we did? We did mu and r square upon n. Do you remember?
Yes, I do remember that because it's
Yes.
the formula you just gave x bar to the normal.
Yeah. So basically, what we're doing is, if this was, we can also write it like this, right?
Oh, you're just
But what?
finding the variance, the standard deviation. I'm sorry, right?
Yes, you're finding the first because you use the standard deviation in the formula, right? Do you remember?
Yeah.
When we did, how do we find out the value of z? Tell me the formula for the value of z.
Z is x minus mu over
X minus mu over
over I think it
standard
was
deviation.
yeah over root n root.
No, standard deviation.
Oh yeah, root standard deviation. Sorry.
Yes.
Sorry,
Root of
root
variance,
variance. Yeah,
basically.
root of variance.
Yes. So that this gets cancelled, so it can also be written as standard deviation, right?
Yeah.
So if I'm giving you right now, you used mu and a standard deviation was this. If I give you mu and this is my variance, how will you find out z? It will be
Sorry, can you repeat
x.
the question?
If this is the distribution I'm giving you, how will you
Yeah.
find out z? X minus mu
Yeah.
upon under root x square upon n.
Okay.
This will give me z, right?
Yes.
Yes. So in
Yes.
this formula, let me explain you this formula. Do you understand this? Do you understand
Yeah.
this distribution? Yeah.
Yes, I do. I do.
I'll just explain you this formula that we're doing, the new formula. So what you're doing in this formula is, this formula says x bar plus minus z r upon under root n. So this is basically when you under root r square upon n, when you under root this variance, this gets cancelled and you get r upon under root n, right?
Yeah.
This is the same thing. They've just multiplied it by z. Why have they multiplied by z? Now understand. So this is my x bar. So what they're trying to do is they're trying to find out the limits. They're trying to find out b and a. So they're doing x bar plus this value so that they get this, and minus this value so that they get this. Do you understand?
Yeah.
Yeah. The z value you will be given or you will have to find out from the table. I'm going to show you questions so you will understand better. Right now it's just theory, which is why it might be confusing. You have written the formulas, right?
Yes, I have. It's also in the book in front of me, so it's fine.
All right. Okay, and we're going to do case 1 now.
Okay, just give me one
So
second so I can copy down the formula.
Yes.
Okay. Okay, let's do case 1.
All right. So the case 1 says this is this is for the confidence interval for mu. Okay. So there are 3 conditions in case 1. First condition is that it should be a normal distribution.
Okay.
Okay. Second condition is the variance should be known. Okay.
Okay.
Now when it is a normal distribution and the variance is known,
One second.
then
Yeah, sorry, continue.
so when it is a normal distribution and the variance is known, then
Okay.
any size sample is okay. If it is a big sample, if it is a small sample, it's okay because the first 2 conditions are applied. Where it's a normal distribution, this is talking about the population, okay? The population has a normal distribution and the variance is known. This means now when these 3 conditions or the first 2 conditions are applied, this means when we convert the population into sample, the sample will also follow a normal distribution.
Okay.
Okay, we don't need to do any approximation to binomial or anything because it's already a normal distribution. Okay.
Okay.
So what does the first case say? The population has a normal distribution. The variance is given in the question. And so if these 2 applies, then for any size sample, the sample will be of a normal distribution. Okay?
Okay. Can we do an example?
Yes, we will be doing an example right now. Okay, another thing I want you to know is, another formula is the width of confidence interval. This might also be given in your book, which is 2z and the variance, the standard deviation basically. Do you know what is the meaning of standard deviation?
No, I just know it's like associated with
Okay,
variance.
so basically it's good that you understand this because it will help you. So basically, if this is the mu, the standard deviation shows how dispersed the values are from the mu. For example, if I say the standard deviation is 2, so this would be if mu is 3. So this would be 5, 3 plus 2, and this would be 3 minus 2, which is 1. So
Okay.
this is the standard deviation. Okay, so what they're saying is 2z into the standard deviation. So they're saying basically even the positive dispersion and also the negative dispersion. That is why they're multiplying it by 2. So you know the width of the confidence interval. You understand?
Yeah.
Okay. All right. Let's do an example now, Naila, of this case.
Okay.
Okay. So if this is true, if it follows a normal distribution, then x bar will follow a normal distribution with mu and r square upon n. This is what we discussed, right?
Yeah.
When it's a normal distribution for sample, this is what happens, r square upon n. Okay, now I'm gonna do a question. I'm just gonna show you a question. Can you take a screenshot?
Yes, 1 second. Let me just get my
Yeah. Okay. Okay. Can you see?
Can you back it up a little bit?
Yeah.
A little bit more. Yeah, okay. Yeah.
All right. So can you read the question with me?
Yeah.
The question basically says the mass of vitamin E in a capsule manufactured by a certain drug company is normally distributed. Whereas
Okay.
they're saying the population is
Normally
first of
distribution.
all, we get our signal that the population is normally distributed. So the
Okay.
first rule applies, okay?
Okay.
The first rule applies is normally distributed with the standard deviation of 0.042 milligram. So
Okay.
the standard deviation is also given. So both rules are being applied.
Yeah.
So
I have a
we
question.
know,
So R
yes,
squared is variance and
no, yes, r squared is variance.
R is
When you
estimate.
underroot r squared, which is r, this is standard deviation.
Okay. Okay. Because I just get confused
Okay.
between those two.
Okay. Just write this down so you know.
I did.
Okay. Perfect. Okay. So they've given us the standard deviation. So we know that the population is normally distributed, and we also have the standard deviation.
Yeah.
Both of the rules are being applied. This means this is a clear-cut case 1.
Okay.
Okay.
Yeah.
This means the sample will also be normally distributed.
Okay.
So sample also has a normal distribution. Okay.
Okay.
So now they're saying a random sample of 5 capsules. 5 capsules mean N is 5.
Yeah.
Was analyzed with the mean mass of vitamin E was found to be 5.12, which means mu is 5.12. So can we now make the distribution of X bar?
Yeah, we can.
We have 5.12, and over here we have
We have a 0.42 over 5.
0.042 upon 5. Okay?
Yeah.
All right.
Yeah.
And the mean mass this. Calculate a symmetric 95% confidence interval. We have to find out confidence interval 95%. For the population mean mass of vitamin E per capsule, give the values of the endpoints of the interval correct to three significant figures. Okay, three significant figures. All right. So what is it asking? It's asking us for the confidence interval basically. What is the
Okay.
formula for confidence interval we found out?
It
It
was
is,
Z.
that is the width.
Oh,
For confidence interval, it is x bar plus minus z
okay.
r upon under root n.
Z under root n. Okay.
Can you solve this and tell me? Now
Yeah,
first
I
tell me
can.
what will be the value of z.
Okay, so first it's gonna be, first I have to find the value of x bar, right?
We have x bar, right? X bar
Okay,
is
yeah, yeah.
equal to
Yeah, yeah,
mu.
yeah. Okay, sorry.
We have x bar, we have standard deviation. We have to find out
5.1.
z. How do we find out z? Remember we
So
did it.
it's just 5.12 minus the mean, but that is the mean.
No,
Sorry, mu.
no, no,
X
Naila, they
bar.
have given us the confidence interval. We have to find out the value of z from here. So
Okay,
this is
no.
our mu, which is 5.12. Our confidence interval is 95%. This means between these values, A and B, it is 95%. So this would be what? 0
None.
0.025
0 to 5.
and this
Yeah.
would be 0.025. So first, what are the steps? I'll do step by step, okay? I'm gonna shift this over here. Wait. Okay. Okay. Firstly, we know that it is 95%. From here till here is 95%, right? We know this is 0.025. We know this is 0.025. So we will say between point A and B. Can you hear me?
Yeah. Yeah, I can hear you. Between
Yeah.
point A and B.
A and B, mu is between A and the probability that mu is between A and B is 0.95. Yes,
Yes.
0.95. Okay, and then we will do, how do you solve this? This is backward
So you
solving,
do,
right? So
yeah,
you do a probability
that
that
mu is
mu is
less than
less
B
than B is equal to 0.975. Then you look for 0.975 in the
in the table.
table. Yes, do that. Tell me.
Oh, why is this so much work? 0.97. 97, 83, 47.
975.
Yeah.
The
I have
probability, okay, not the value. The probability. Look for the probability.
975. Okay, my bad. 975 is 1.96.
Yes, perfect. So this is probability. The z value is z is less than
1.96.
b is equal to 1.96. So now we
Okay.
have our z value.
Yeah.
Okay. For this formula, we have our z value. Can you plug everything in and tell me the value confidence interval values?
Yeah. Do I have to do plus and minus?
Yes, because you have to find this and this. You
Okay.
have found out the 1.16. This is the z value. Right now, you're finding out the x values. Okay.
I already know the x bar value. It's 5.12. Right?
5.12.
Yeah.
No, 5.12 is the mu. This is 5.12. You don't know A and B.
But didn't you say that the estimated x bar was the same as mu?
It is. Of course it is. This is 5.12.
Okay.
I'm looking for A and B. This is the confidence interval,
Oh, how am I supposed to
right?
find that?
By using this formula. This will give you A by minusing. Basically, you're going to find this. This will give you
Yeah. Okay, one second.
this.
Let me try it, and then if I don't get it, then I'll ask.
Oh, okay.
Is one of the values 5.16, and the other one is, one second, is 5.1?
It's 5.16. That's correct. The
And
other
then the
one is
next one is,
incorrect.
it's 5.083.
Yes, 08. Did you read in the question? We have to answer in 3 significant figures. So
Okay, I didn't get
5.08.
it.
All right. So,
Yeah.
Naila, what is this? This is basically you found out A and B. This
Okay.
value and this value. Now,
Okay.
I want you to understand something. This, do you see this is mu? This is basically X bar. So this is this, right?
Yeah.
Can you see the screen?
Yeah, I can see it.
This is basically this, right?
Yes.
Now you're adding to find B and you're subtracting to find A. So what this is, do you understand this part of the formula? This is basically this part. Do you see?
Yeah. Yes, I get it.
And then this is this part. So when you multiply this part of the formula by 2, you get this whole thing, which is called the width. I made you write down the formula for the width, right? The width of the confidence interval.
No, you didn't. Can you repeat it?
I did. You did write it. You wrote 2z. Remember?
2z. No, I didn't write it. 2z. 2z what?
Wait, I'm telling you. I'm telling you. Wait, relax. It's okay. Take 1 minute. So the formula for that is, for the width is this part into 2 basically. So 2z r upon under root n. See, do you see this is this part only. We're just multiplying it by 2.
Okay.
And why are you multiplying it by 2? To get this part. You get it?
Okay. Yeah, I do get it.
Do you understand? Do you understand the logic behind everything?
Kind of, yes.
Yes?
I do.
I'm going to
Yeah,
give
like
you...
I get the hint of it.
Okay, I'm going to give you a few questions. You do those, it will start making sense. We have 5 minutes. Let's do another question as well, okay?
Okay. And then you can give me some homework and I'll finish it by the next one.
Yes. Okay. And if you you will take another class, right? 3 classes a week. So
Yeah,
what
so
we can
starting
do
this
is,
week, I think.
okay, what we can do is we can either increase the Sunday class to 2 hours if you're fine with that.
Do you think 2 hours would be too much?
Do you think 2 hours would be too much? Would it be too much for you?
A little bit.
Little bit? Okay, that's all right. Or what we can do is we can make both our classes 1.5 hour long. Would that be better for you?
Yeah, that's actually better.
Yeah, because I think in 1 hour we're not able to cover much.
Yeah, right. So
Yeah,
we
do you want to do this?
Yeah, this week we can have another class during the week, but then from next week we'll start
Yes,
like 1.5,
yes, perfect. Let's do that. Okay. Perfect. Okay. Okay, I'm gonna okay, let's do this question. Let me see. Wait.
So after I find the A and B value, I'm done. I don't need to do anything else.
No, did you see I wrote the confidence interval in brackets? That's how you give the answer.
Can I see it again? Did you erase it? Or can you
I
write it again?
erased it, but you write it the first value over here, bracket the second value.
Okay.
Okay?
So 5. The greater value goes first, right?
No, the greater value goes in second.
Okay.
Let me find a question for case 1. Okay. Just take a screenshot of this question.
Okay. Okay. Done.
Then, okay,
Yeah.
let's read it.
Question 5?
Yes.
Okay.
So it says the pulse rate of 98-year-old children chosen
Yeah.
randomly from different schools. So we have N is 90, right?
Yeah.
From different schools in a city gave a sample mean of 86.6. So we have 86.6 as mean beats
Mm-hmm.
per minute and an unbiased estimate of population variance of, so our sample variances. And unbiased estimate of population variance means an estimate of the population variance, which is a
Yeah. So
sample
it's
variance, right?
yes.
Yes. So this
Yes.
is the
And you
sample
can tell
variance.
it's a sample variance because it also says S2 instead of R2.
Yes, but in questions they will not make it this easy for you. They will not tell you S2.
Okay.
Okay.
So what will
Okay.
they tell
So
you exactly?
they just write down an estimate of the population variance, or they will tell you the variance of the sample is this, or the variance of 5 people was this. Okay. So you
Yeah.
will have to
Okay.
figure out that from 100 people, if they're taking 5 people, then that is the sample. And if they're
Okay.
telling you the sample of 5 people, which is the sample variance. Okay.
Yeah, the only
Okay.
difference is that you have to do n-1 and then just n, right? Between
Yeah.
the sample variance. Okay.
Yeah. If they
Okay.
have given, if they won't have given you the sample variance, you will
Yeah.
have to calculate it on your own,
Yeah.
which is when you will use the variance formula. Okay.
Yeah.
Calculate a symmetric 98% confidence interval. So we have to find out a confidence interval of
98.
98% for the mean pulse of all 8-year-old children in the city.
Okay.
Okay. Okay. Now let's solve it together. Okay. So they have given us the mean. They have told us they follow a normal distribution, or they
Yeah.
haven't.
They
They
haven't.
haven't. They have
They
not
haven't.
told us. So this is not case 1.
Can we just do it like it's case 1?
No, we can't. It's different.
Okay.
Okay, let's just do it like it's case 1. It's okay.
Okay.
But the answer won't be the same, obviously. But let's
Yeah.
just do it. Okay, let's just
Okay.
understand the question.
Okay.
Suppose this was a normal distribution. Okay, so
Yeah.
it was we have a normal distribution, and we also have the sample we also have the variance, right? So
Yeah.
this means that what does this mean? This means that it is a case 1. So in this case, what we do is we have a normal distribution of 86.6 and 106.09 upon 5
Okay. 86.6
upon 90.
106 upon 90. Okay.
Yeah.
Yeah.
If this is a normal distribution, okay. Okay.
Okay.
Now what you do is you have to find out the confidence interval for 98%. What
Okay.
is the first step? The first step is to find out what. First, you use this formula, right? X bar plus minus Z r upon under root n. So you have everything, but you don't have z. So first you have to find out z.
Yeah.
To find out
So
z, what you do, you say
then
that you make the graph. You say this is A, this is B,
the
and
middle is
this is
86.6.
mu. Yeah, this is
86.6.
86.6, yes. So you say mu falls between A and B. The probability for this is 0.98, which is 98% confidence interval. Okay,
Okay.
so they are basically saying we are 98% confident that the mu falls between values A and B.
Yeah.
Okay, so
98
this
by
is
2.
this says this is this. So this would be what?
Um,
0.0 divided by 2.
it's gonna be 2.06. 2.6.
This region.
Oh, okay. Sorry, my bad.
It's okay. This is going to be 0.01, I think.
Yeah, 0.01, and the other one is also gonna be 0.01.
0.01. So you do so you take the greater value and you say probability that mu is less than b is 0.98 plus
Yeah.
0.01,
Yeah.
which is 0.981. No, 0.99, right?
0.9. Sorry, my brain is not working. 0. Point, yeah, it's 0.99.
Okay, so then you look for this in the graph.
1 second, let me look for it. 0.99. There's 0.9901. Is that fine?
Yeah, no, take the lesser value then.
Okay, it's 0.9898.
Yes, take that. So it is
2.32.
0.9898. Okay?
Yeah. No, no, no.
Or
It's 0. Sorry, it's 2.32.
2.32.
Yes.
Okay, this is what you take. And then you put this in the formula. You do plus minus, you find out the confidence interval values. Okay?
Yeah. Why do you take the smaller value and not the bigger one?
Because you tell me if I'm saying this is the probability. Okay, I'm taking this probability. It's better that you take a value from here rather than here, right? Because this is not inside our region. You can never take more, right?
Okay.
Does that make sense? I don't think that makes sense to you. I will explain again.
Okay.
For example, you have this region. Now, I'm saying you have to find out this, right? From here, you have to find this value, right?
Yeah.
So what you're saying is you're finding out this value, a value greater. So it's better that you take a value over here because this would still give you the value where the probability lies. Over here,
Okay.
you're taking a greater value, the value would be greater and the probability is not even included, right?
Okay.
That is why it is always better to take a smaller value where the probability is included, okay?
Yeah.
Because either ways, 0.9898 would round off and become 99, right?
Yeah.
But the value that you would take after this would become 10
Larger.
roughly, larger, right?
Yeah.
That is
Okay.
the point.
I
You
found the
understand?
two values of A and B.
Okay, tell me.
84.08 and 89.119.
Okay, 89.2
119.
basically, right?
Also, for R in this, I did root of 106.09. Is that okay?
Yeah, that is what you have to do.
Okay.
That's correct. Okay?
Okay.
So you found out this, perfect, you write it like this, okay?
Yeah. Okay. Done?
Now, what does the second part say?
I don't know. 1 second. I didn't read it.
If in fact the 90 children were chosen randomly from this attending, this is the question we were doing, right?
Yeah, yeah,
Yeah.
I have it.
If in fact the 90 children were chosen randomly from those attending a hospital clinic. Comment on how this information affects the interpretation of the confidence interval found in part A. Found in different schools in a city. Randomly among the two. Children, 80 children. So randomly from those. And okay, let me see. 5 So they're saying from attending a clinic. Okay, they're saying if the children were 90 children were chosen randomly from those attending a hospital clinic. Initially, they chose the children from different schools, right?
Yeah.
And they were 8-year-old children, right? But right now they're saying if they randomly picked 90 children from hospitals, how would this affect the interpretation? How would this affect our answer? This would affect our answer because they have given us a mean for only 8-year-olds. Our mean
Yeah.
is not valid for other children greater or less than 8-year-olds, right?
Yeah.
So our estimation would be invalid.
Okay.
Okay? That
Yeah.
is basically what you have to tell.
Okay.
Okay? You understand?
Yes, I understand.
Okay.
So it was just making
Now,
a statement, right? So you don't have to.
no, there's no calculation involved in this.
Okay, fine.
Okay. Okay, so Naila, I'm gonna send you some questions of case 1. Just message me to remind that I have to send you questions.
Okay,
Okay,
I'll message you tomorrow.
I'll send them to you by tomorrow. And in the next class, we'll do case 2 and 3, okay?
Okay, and when is the next class?
The next class is on Thursday. Okay, you need another class this week.
Yeah.
Okay,
Do you want to do
we
tomorrow?
can do, no, we can't do tomorrow. We can do,
Wednesday?
yeah, we can do Wednesday. I'll tell you
Same
the
time?
time.
Okay, fine.
Same time, yes, probably the same time.
Okay, fine.
Still, ask me again, I'll tell you, okay?
Okay, fine.
Okay? Okay,
Okay,
thank you,
you.
Naila.
Bye, bye, bye.
Bye-bye.